So let's get started with some introductions. First, we have a couple of experts here on hand to help you guys think about some of the GCC challenges you might be facing. First, we have Daniel Wong, our Chief Security Officer here at Skyflow. He led security at Oracle, was a key member of companies like Salesforce, CrowdStrike, and previously at Yahoo. Daniel, care to say hello? He's on mute. It's okay. We'll get started without him. And Manish Ahluwalia, he is the field CTO here at Skyflow. Previously, security leader with depth of experience at companies like Cisco, Cloudera, NerdWallet. Manish, care to say hello?
Hey everyone, looking forward to an engaging conversation with you all.
That's great. All right. So before we get into the content, we wanted to start off with a bit of an agenda walkthrough just to give you a better sense for what you'll be expecting throughout today's content. So we're going to start off talking a little bit about what we're seeing today with customers that we talk to on a regular basis around challenges they're facing with offshoring and their global capability centers, or GCCs. Next, we'll get into maybe some of the blockers that have emerged for offshoring data. And then we'll talk a little bit about how companies are solutioning for some of these challenges. We'll cover a brief overview of the Vault architecture that can help you think through one solution, at least, that can help you think through how to tackle some of the challenges. And then we'll jump into the Q&A. And of course, there will be a little bit of time on Skyflow itself as we are the presenter. All right. And with that, I'd like to pass the baton to Daniel, and he can take us from here.
Thank you, Lenny. Pleasure to be here speaking to the group today. Indeed, offshoring has been a hot trend for quite some time. Earlier days, there were manufacturing offshoring. Then starting around late 1990s to 2000, Internet made many compute and communication infrastructure widely available. And this is when offshoring really started to accelerate. Initially, many large enterprises set up offshore offices. The main motivation was cost savings. The regulatory landscape during those days were pretty relaxed. It was really up to the enterprises to make it work. There were location, facility, people, legal resources. There are all these kind of different challenges. So the enterprises need to have enough resources to make those things work for them. Fast forward to today, the offshoring operations has evolved a lot. It went from basic operations to later on, these offices start to specialize in certain functions. They take care of advanced security functions, monitoring, production operations. And in the current days, many of these offices, in fact, have become strategic partners in development, and we call them innovation hubs. If you look at many industry leaders, the large leaders, they set up global offices around the world to take advantage of the talent pools and, of course, many of the geolocation benefits from different offices. Together with all the digital offshoring comes with data sharing. And that's the core of the challenge. How do you balance scale of the offshoring work with data security and compliance? I'm sure we have all noticed in recent years, all the new regulations and rules put together by various countries, how to handle personal data for the individuals. This is like an alphabet soup. You can look at, there's GDPR from Europe, CCPA from California, DPDP from India, HIPAA from US, PDPA from Singapore. There's all these regulations. The intention is really to help to make sure that their citizens' data is protected. And due to cost and complexities of all these different regulations for different rules and even different data types, many times these have become, the compliances have become blockers to the GCC implementations. Well, one recent regulations is the recent DOJ rule, Department of Justice rule on bulk sensitive data transfer. It's also known as Executive Order 14117. The goal of the executive order is to block any hostile foreign access to US bulk sensitive personal data. In fact, this is a pretty timely rule, I would say. As you know, the machine learning technologies have advanced so much that these algorithms can get a lot of intelligence from data sets. So the intention of this rule is really to make sure that the data set from US citizens, they are protected. At a glance, the rule tries to eliminate any non-essential sharing. If you are in the business of selling data to another country, to another offices, to one of these 6 countries of concern, the rule basically banned the operation there. But there are also, of course, legitimate operations, such as if there's vendor relationship, there are like offshoring offices indeed, or sometimes there are global organizations who have offices around the world, including these locations. So there are legitimate cases of transfer, and this is called restricted transfer. It covers data that is all the personal identifier, any government data, and of course, healthcare data. Most important to us will be the security requirements that's defined by CISA. They define exactly what kind of data security features or capabilities are needed in order to do the restricted transfer. In terms of dates, we have already passed the final dates. In fact, 2 days back was the last part of the rule has started, so everyone is supposed to be in compliance right now. There's of course serious penalties of if you are not compliant with the data transfer there. I'd like to dig a little bit into the CISA's security requirements. I would say there are 2 kinds of requirements there. The first kind is we call organization and system level requirements. You will find out these are pretty much the basic security requirements on datasets. These are the basic ones that you will find from PCI, SOC 2, and ISO requirements. They want you to have strong lifecycle, strong organization, and mature process to handle those data and keep track of where things are, basically. So those of us who have to get certified with other certifications should be quite familiar with these requirements. And then there are specific data level requirements. In order to safeguard data and limit the exposure of the data set. Data specific call out data minimization and masking, which is about who you need to expose the data to. And it should be absolute minimum to what you need to share. Encryption, which is pretty standard at rest and in transit. And the rules also talked about advanced protections because we should be able to go over that a little bit. There are different data sets, they require different attention to make them truly de-identify. There are advanced algorithms such as homomorphic encryption or differential privacy. There's one thing that we like to call out, which is quite important and unique in this executive order, which is that they did not state very well how to get things done, but it stated the what part, which is the requirement is to make sure that the data is fully de-identified so that it cannot be re-identified back um, to the original personal data. So so sometimes in some cases, simple de-identification may not be sufficient. So what are the best practices out there for compliance and engineering leaders to address these needs without breaking the bank, breaking the application, breaking the systems? At Skyflow, we spoke to many organizations, investigating these requirements. And they mainly fall into a few buckets we like to call out. And then we'll discuss technologies that what we can do. The first one you will hear from many of the requirements is really about data residency. They want to make sure that any personal data stays within that region. GDPR, HIPAA, DPDP is the first and foremost. They like to keep data within their regional boundary. Second one is cross-border data transfer. That means if there is any data transfer, we'll need to ensure that both ends of the communication and transfer have equivalent adequate security between them. So that's another important criteria to do design and thinking about any data transfer. And then there's masking and tokenization requirements, because many of the of the projects, there's different needs to do masking and tokenization. That's one common technology to de-identify data. And finally, any solution that people are putting together, you want to make sure that it does not make the matter worse. I'm sure you've heard about there are organizations. They have so many copies of sensitive data in so many places. When there's a DSAR request, they just couldn't figure out where to delete the data. So one key requirement is to make sure that the data will not become duplicated in many more locations. At this point, I like for Manish, and Manish helped many customers to implement solutions for different use cases to address these different needs. So Manish, would you be able to share your thoughts on these subjects?
Awesome. Thank you very much, Daniel. Hey, everyone. As Daniel's very nicely laid out for us the landscape of the problem, obviously there are a lot of problems talking about you would have to go through, solve when you're trying to set up a GCC. But today our focus is mostly on data, because if you can't solve those problems, you don't really have you can't really get started with your GCC because you don't know what to do. So a lot of these problems that Daniel mentioned are solvable on a piecemeal basis. And we all know the problem with that approach is that you don't really have a good handle on the risk you are leaving on the you are exposed to. It doesn't also give you a good understanding of the timelines and the cost you will run into when trying to solve these problems. So I think this is a good point in time to take a small step back and figure out, if I am going to be dealing with data, and you obviously are, what are the approaches, a systematic architectural approach where you can have a holistic understanding of what your systems are supposed to do and what posture that will leave you with, so you can analyze it systematically, plan in advance, and have predictable outcomes for what you do. So let me take one more step back, and instead of trying to give you Skyflow's perspective on that, let me start with a neutral party. A few years ago, this is already 3 years old, as you can kind of see, IEEE had this article about the data privacy vault architecture. Skyflow will give you a data privacy vault as delivered as a service. But let's understand what the architecture is doing from the perspective of a neutral expert body. So let's take a look at the traditional approach. So a very simplified, multi-tiered application setup where you've got a whole bunch of front-end applications talking to a whole bunch of back-end applications that write to a whole bunch of databases, and then there's some data warehouse, data lake, and you do analytics, you do real-time data serving, etc., right? Your operational and your analytical store, everything's like compressed in their picture on the top. So it's a simplification, obviously, but it's a good simplification. If you take a look at this, if your application has to deal with data, or you're ingesting data some other way from third party, etc., it ends up in your backend, coming through your load balancers gateways. That backend will need a database or some databases. So it's in your databases. That database gets through an ETL process, dumped in some data warehouse where you're doing some analytics, some other offline processing on the back end of all this your systems, right? Now that's where the data is going. You've got backup tapes going on everywhere. You got a disaster recovery setup, which sends the data to a different region. All of these are dumping out logs. You've got dashboards, reports, everything. So you, at this point in time, you have the exact data sprawl problem that Daniel mentioned. And you can go whack-a-mole, like I said, and kind of whack each of these moles one by one wherever they pop up. Not a great place to be. The data vault architecture essentially has the observation that most of your data flows don't actually need sensitive elements in them. Even if they need to send it over to a downstream thing like your gateway, API gateway, or your load balancer, your GraphQL server, it just needs to take data from point A and send it to point B, right? It didn't really need to read the data to fulfill its business function. So at some point in time, wherever you're convenient or you can implement easily, you can take the sensitive parts of the data out of your stream. That's the red arrow in the bottom picture, and pull it out of your flow and send it to the data privacy vault. So the red arrows, the sensitive data we are worried about, only lives in the data privacy vault. And you get pointers back to this data so that you can operate on. And there is a whole bunch of detail there. But to simplify, you get the ability to refer to that data, send that back to your application flows, which can now send it wherever it was going. You can basically make sure that um, your uh, your systems remain unchanged and they're still dealing with pretty much the same architectural diagram that you had before, just with this little piece that gets added onto the side. And the capabilities of this piece are basically that it can handle these data securely in a compliant manner, but also it enables the functionality that you had in your thing. So for somebody who did need PI, because obviously you do need it at some point in time, they can go to the vault, properly access control, properly audited, and get access to the data to complete their functions and meet your overall business obligations in a way where the vast majority of the systems are de-risked. In this case, from a security perspective, but obviously with its relevant compliance implications as well. So that's basically the whole idea. Now, if you may go to the next step, let's take a look at what this, Daniel, could go to the next slide, please. Let's take a look at the data privacy vault piece itself. Let's do a little bit of a zoom in and see what are the capabilities it provides that it and what does it offload off the rest of your systems, your existing setup, for instance, right? You want a data privacy vault to be able to find sensitive data for you, to isolate it, move it away from your regular storage systems, your data warehouse, your data lakes, your OLTP databases, move it into the data privacy vault. That's the isolate part. Protect it in a compliant, secure manner with proper encryption, tokenization, etc. Help you do access control and governance on the data from the access control perspective of basically making sure that only legitimate parties that have a business need to touch the data in a compliant manner. And all data use is audited. So you can meet your data subject request rights requirements, obligations. And since it doesn't quite show it here, but Daniel covered this, so I'll mention this. You also have data subject rights in GDPR and CCPA. And if your data is isolated, as the second box shows, in one place, you have one place to go delete your data. You don't have a data sprawl problem. You can sprawl the rest of your data all you want, but for the part that I would basically say go delete, you know exactly where to go to, and you've deleted the data over there. If you can move on to the next slide. So what does this mean from a data-centric view? We've been talking about architecture right now. This is what you change in your systems. Here's how a system behaves. We've zoomed into one of those system components like data privacy vault. Let's take a look at this from a data perspective from your users. So we've shown a couple of examples out here. So Skyflow is basically the vault, which helps your existing data stores maintain the bulk of their functionality and the bulk of the data. And Skyflow will basically selectively, in an audited access control manner, recover parts of the data as needed for the business use case as defined by your policies. So you may have a policy which says US InfoSec support gets all the data it needs. It needs social security number to find out there's a fraud happening, etc. The call center in Mumbai just needs to be able to identify people to make sure they've got the right person on the call, and maybe all they need is the last four of the social security number. So this, in a zero trust manner, Skyflow will expose only that part of the data, not the entire data, and not expect the call center software or the call center person to respect the obligations of not exposing the social security number. Skyflow just does not make it available to them at all. All you get by policy is the last four of the social security number. When analytics are being performed, no analytics should need any use of social security number. The entire thing is hidden. You probably don't need much more, but in this example, we're showing that how you can partially redact parts of the data also. It's not just all or nothing. So you can choose to redact part of the name, part of the email, etc. It's your vault. We are a platform, so you choose your policies. So that's the quick to summarize what I've been talking about. You can take in a well-defined, well-understood architectural perspective. By using the data vault that we provide as a service, you can meet a whole bunch of compliance and security needs and guarantees. And it will basically do it in a way that your business flows, your data flows, will respect the obligations you have and will, in a zero trust manner, expose only what is needed by that business service, by that use case, to expose the minimal data needed to perform your obligations. If it so that's kind of the summary of what I was presenting as the data vault architecture. Daniel, back to you.
Awesome, Manish. Thank you. I know that whenever we speak to customers about, hey, using a vault system, they will be concerned about if the new vault is going to break existing applications, legacy systems. For example, if they replace data with tokens, or replacing or adding the system into the overall architecture, would it in fact impact data flow? Can you please comment on that?
Obviously, a very natural thing for someone to work about because I just showed you architecture that's changing things. There's a component that got added to it. There's you're going to change, as Daniel said, some data elements, obviously, because you don't want your name in there. So something's got to go replace the name. You're going to encrypt it. You're going to tokenize it, etc. So how difficult is it for me to actually adopt? What breaks? So firstly, I want to point out the vault that Skyflow provides is available as a service using a simple web API, REST-like API. So any client you want to use can go talk to your vault. But maybe that's a little bit too much work. You prefer using an SDK. We've got SDKs in multiple libraries that you can use there, where you don't have to deal with the HTTP calls. You deal with data elements, data objects. But sometimes you have legacy applications, and you would like, I can't really go change my legacy application at all. I could just can't touch the code. We've got ways of where instead of your application figuring out that I'm dealing with PII, let me go give the PII to somebody else and get a token back, or vice versa. I have token, I need the PII, let me go and ask for a detokenization operation. We've got facilities called functions and connections, where you can put a component in front or behind your application or both. Kind of think of it like a proxy, and your application, when it reads data, it doesn't realize that it's reading through the vault system. It is the connections proxy kind of handles it for you. Writing can perform the reverse operation on the other side. So your entire IO for your system can basically be, your system can basically kind of go inside a sandbox where it doesn't know it's dealing with a vaulted system at all. In terms of the second bullet point, we have you can work with a token. That's great. Maybe your legacy application expects all phone numbers to look like phone numbers. Maybe it expects social security numbers to have a 3-2-3 digit format. We can make sure that the tokens we give you, that we replace, will meet the data validation rules that your applications expect. So you don't have to go touch them. You don't have to modify them to say, hey, don't worry about this. This is not a token. This is not an SSN anymore. It's a token. It's going to look different. You don't have to go make the change, because you can make sure the tokens look like social security numbers. If they're breached, you only breached tokens. They look like social security numbers, but you can't go open a credit card, a line of credit based on that social security number. And that's really what you care about, that the real data doesn't leak. So that should hopefully answer those concerns.
Nice.
And this one is sorry, if you can just go one slide down.
Yes.
So this is an example of the connections thing that I mentioned, because it may be a little hard to understand in words, but effectively the point is, if you have something like in our example, this is from a customer deployment. So they had MuleSoft. So effectively their front end, which actually is dealing with PI because it's interacting with the customer who enters their own PI and expects to see it back. They don't want their microservices in their backend to be aware that of the sensitive data, to have to manage them, store them, etc. So in the MuleSoft gateway, they basically and they didn't want to touch their um, several years old microservices. So they basically put in a connector, the Skyflow connector in the MuleSoft gateway. So their applications were completely not aware. And this north-south traffic was partially in the clear, partially all tokenized. The applications only see the tokenized part. So without any change to the microservices, we just deploy this and overnight everything's working securely.
Nice. Can you comment further on applications such as analytics and machine learning? Would those computes be affected by all these, token and different things?
So that's the question when somebody says, "Oh, all right, hold on, you replaced it with a token. What happens to my data warehouse, which is now storing tokens?" So obviously, as the whole architecture said that you, for legitimate use cases, you can go back to the vault and you can configure your own policies to say my this particular analytics application does have access to social security numbers. Maybe it's doing a fraud analysis or some such thing. Your use case, right? But that's kind of a little bit of a cop out saying that, well, like I've got 100 applications, they can all go to the vault. That's a cop out. In most cases, when you are doing analytics on sensitive data, you don't actually need the sensitive data itself. You need certain properties on the sensitive data. You want to find out, you want to trace a customer records. You want to group your customers by zip code. You need the ability to group them by zip code. You don't really need to know what the exact zip code is. To track a particular customer, you need a unique way to follow the customer, and maybe you have a unique ID, so you don't, it wouldn't be a PII challenge anyway, or maybe you did not because you were using, as many some systems unfortunately do, you using a sensitive identifier like an email or such as the customer ID. Well, with this approach, what we can give you is we can basically give you tokens that maintain your your needs for the referential integrity. So in the zip code example, we can give you tokens for the zip code that maintain your groupability capability. So the tokens will look like tokens. They're not the actual zip code. So you can't mail me a letter based on that zip code because it's not a real zip code. But what you can do is you can continue doing a group by, because we made sure that the tokens we give you will maintain the same grouping in your tokenized data as your original data would. Right? So that's a fairly complex example, but hopefully it illustrates the point that you can now continue doing your queries on your data lake unchanged, and you will get the same results in your analytics as you wanted as if you were using the sensitive data. So the outcome is you maintain your data relationships and your analytical workflows, and you keep your PI secure.
Thank you.
And this is an example for showing that. So what's happening in tokenization, let's take a look only at the first name column. The rest of it is just for you to follow along. So we tokenized. So instead of storing the first name in the top view, we basically replaced all of them with token. But in this case, all I wanted to know was I wanted to know that I can basically track a user by their first name in my example. I can track the user through my analytical database, the same user. So in this case, Donald, that's the first name, has what we are calling consistent tokenization. So a Donald will always have the same first name. A different first name will always map to a different token. So you can kind of see now you can find, I don't know why you would want to do it, but you can find all the Donalds in your database if that was your use case. Just to illustrate the concept here.
Thank you. What about cases that the legacy applications involves unstructured data such as videos, files, or audios? Can you comment on them?
So a bulk of the data in the real world is actually not in nicely structured tables like we were showing with us. Daniel called out explicitly in a first name column sitting next to a ID column, etc. A lot of data, unfortunately, is in completely, like I have images, DICOM images for medical use cases that mostly don't have anything about me, but will have my name right on the corner somewhere, right? Or a KYC use case where the document needs to have sensitive information to have for it to serve its purpose. And you need to store it and maybe very selectively expose just parts of it that are needed for your business use case, right? So this entire solution that we're talking about, while we've been talking about so far in terms of structure of the data, first name, email, etc. And part of the thing is that that is kind of how regulations identify which parts of the data, subjects data are actually covered by what rules, right? We know that those data elements show up everywhere in a whole bunch of data formats. I mentioned a couple of examples, but you could have like a call center recording where the customer spends the first minute or so identifying themselves to your agent, right? What we want here is we want to have the same capabilities that we're talking about, applying not just to structured data, not just to your Snowflake, Databricks, etc., to apply to all data you've stored in your data warehouse, your DICOM images in my example, or KYC images, right? The Skyflow solution does exactly what we've been talking about for cases where you have structure explicitly called out and schema like a database, but also for cases where the data is just lying mixed up along with a whole bunch of other stuff, like my audio call center recording, for instance, or the KYC document. We can take our AI powered solutions. We'll basically do natural language processing, audio detection, image detection, whatever is needed to figure out where the sensitive elements are and deal with them exactly the same way as they were dealing with them on the previous example, where you can pull the first name out of an image for a driver's license. You can store it securely in the vault. For the needed use cases, you can bring it back. You can give me the original driver's license for an agent who's allowed to see them. And for an agent that's not allowed to see them, they can touch the files, they can do backup on the files, etc., but they can't actually find out what the name of the person is behind the thing. So we can automatically discover and protect that as part of your workflows without you needing to go manually classify, identify the data. And our system is extensible. You can tell us what elements are sensitive for you, for your use case.
Thank you.
And this is an example of a pipeline like that working. So your data lake was storing files. In this case, it's got like a whole bunch of files of very different structure. It could contain like images, DICOM images, etc. And you can have your documents and audio files, etc., coming in. And before you go dump it in your data lakes for your long-term storage, you can plug in Skyflow. Our system can detect. It will tokenize the sensitive parts. It will redact all in one workflow. And what you end up getting as part of your ingest process is these cleaned out versions of the data that are stored. But like I said, the logical relationship between the data elements we pulled out and what we replace them with are stored in a structured manner. So we can reconstruct the data as and when needed. Awesome. So basically, let's talk about why are we doing all of this? What have we gotten out here? So the vault will give you like advanced encryption and access control technology. So this is from a very technical perspective. You can understand that your sensitive data was stored in the vault, but we are taking good care to make sure it is stored with top grade encryption, whatever is the latest thing at every single layer, at rest, in transit, etc. Right? So the vault itself is meeting your security obligations, your data security obligations, because obviously you don't meet any of your compliance obligations if you can't secure your data. We do allow access, but it's at a very fine-grained access control manner that you define your policies on. Um, and what this gives you is it gives you the ability to do data isolation. So we didn't talk too much about this part, but you can essentially figure out where the vault lives is now different from where your database lives. So you've isolated your sensitive parts of the data to the geography you want to keep it in, and you can still keep your data lake where you want it, where you needed it for your most efficient or legacy reasons, whatever, right? And as a result of all of this, you've gotten a much better posture for compliance. And this will enable your global operations, while keeping your sensitive data in a particular geography if you needed to keep it, like GDPR, etc., and meeting your legal and operational needs while keeping the data secure in the vault. So just to a quick summary of what you get. We know that compliance blocks offshoring, as Daniel mentioned, but the data privacy vault architecture is a way for you to address those challenges. And that gives you the ability to implement a GCC solution that doesn't break your workflows and is still compliant and keeps everybody happy. With that, Lenny, I'll hand back to you.
Awesome. Thank you, Manish and Daniel, for today's content. I think that was really helpful to give folks an understanding for how compliance challenges can impact your data offshoring challenges. So let's get started with a few questions we have coming in. So first one was, you guys covered some various global regulations. Are there other requirements that maybe a Skyflow Vault could help support, such as GDPR?
I'll give some responses first. GDPR, of course, is one of the things I've listed as one of the uh, global privacy requirements, right, for many of the EU customers. And yes, Skyflow, anywhere there's a requirements on data security and compliance, governance, local residencies, Skyflow has capabilities to put data in anywhere in any region of the world, basically, to address your data privacy needs.
Excellent. Could you expand a little bit about that? Any region, any data? How is that? What does that mean exactly? Like,
There are depending on the regulations, I would say that there are different regions of the world and there are different requirements. Some of them there's strong local residency requirement. You need to keep data around there, and some of them actually there's a adequacy in like EU GDPR. As long as the countries are listed as adequate countries, you can share data between them. Some of them are more loose. You can use things such as a SEC, standard contract clauses, or BCR, right? Binding corporate rules to make sure that both ends of the data transfer communications they address specific requirements. As long as that's the case, and they will be happy about it. So these are the common cases that Skyflow can all help and address.
okay, excellent. Thank you, Daniel. Next is maybe a little bit more of a technical question. When we talked a bit about the DOJ rule during that currently is governing bulk data transfer, um, question came in around how specifically does Skyflow or maybe this satisfy the Department of Justice's re-identification requirements? This feels like maybe a question for Manish.
So like Daniel mentioned, there are a bunch of requirements, and we aren't lawyers, we aren't your lawyers for sure. So you should basically make sure you have an understanding for whatever you're doing, how it applies to your business. What Skyflow is a platform, and like I mentioned, we've got a whole bunch of capabilities to meet a whole bunch of different compliance type requirements. You would essentially map your business data elements, your transfer rules to the requirements as specified in the DOJ rule, or any compliance for that matter. And you'd basically enforce those rules by storing the correct data elements, the relevant data elements in the vault, and basically putting on the correct policies for what gets exported in terms of tokens, what get exported in terms of plain text. And by setting that appropriately, you can put safeguards for sensitive data does not go out of the EU in an unencrypted form. For example, to tie back to the previous example that question Daniel was answering.
Got it. And is there some sort of like logging functionality in case of, regulatory conversations, stuff like that? Maybe you speak to an auditor or what happens?
Correct. So, excellent point. We do any data access through the vault is always logged. So you have the ability to go trace any use of the data. And also since you know in this case whether the use itself was exposure of the entire data element, like the use case where we were de-tokenizing the entire social security number for the US InfoSec people to see, versus use from the Mumbai call center where we did not give them the full data element. So you will have a full audit, full trace of what parts of the data element, not just like social security number, but what part of the social security number was viewed at what date by whom.
Hmm. So maybe in the event of a data breach, would this also help protect that data at the underlying data?
So a data breach at a low level like a storage in this case would have pretty much no exposure to any sensitive data because all of that is being stored in the vault.
Hmm.
And you have non-sensitive data and tokenized sensitive data. The tokens are completely irreversible back. Doesn't matter how much compute power or quantum computer you throw at it. It's simply not reversible back to the original one because it's not an algorithmic translation at all.
Hmm.
So your breach obligation at that layer are pretty much gone. Now your minimal breach obligations would be kind of like a compromised credential for the infosec person or a like your call center people are compromised in some way. So those you would have to handle from other solutions like identity management, etc.
Understood. I think that's pretty clear. Thank you for the depth there. All right, so let's talk a little bit about maybe implementation on Skyflow. We've heard a lot about a variety of different solutions that you could apply, different masking rules, policies, and technologies that are available within the vault. Uh, what does a typical implementation look like? How long does it take to get up and running?
So let me take that one, Daniel. So what we're talking about here is going from the original, the orange picture where everything's bad and things are in red to the clean picture, right? And the vault is actually very flexible. It doesn't particularly care about whether the data, sensitive data that's coming in is coming from the front end. We've got JavaScript plugins you can drop into your front end so you never see anything, right? But it doesn't care if whether it's coming from JavaScript, etc. You could basically not care about integrating the vault anywhere except to your data lakes because maybe that's where you operate. You're the VP of data. You operate your data lake. You want to basically make sure your ass is covered. To put it differently, we can basically sit in front as part of your ETL pipeline, and we have products called pipelines in this case that do precisely that. You fit it in your ETL pipeline, and basically the data coming in from the left is taken out, put into the vault, and goes to the right. So you can choose how you want to implement the solution, what will be the fastest, biggest bang for the buck for you, and expand out from there. You don't have to basically boil the entire ocean and say like, well, today we are insecure, tomorrow we want to be completely secure. It's a journey, and you can choose your steps in the journey. Like we mentioned with the tools like connections and pipelines, you don't have to go changing your code to get the benefits of what Skyflow does.
So does that maybe impact performance? Like how do it seems like you're putting some sort of, ETL layer in between the data. How does that impact?
Correct. So for all of these, so I mentioned various solutions, right? Like you can put in a JavaScript plugin for your front end. You can put in pipelines, connections for different things. So all of these, our performance numbers are very good. They obviously you are looking at different things, different performance characteristics when you're looking at these different solutions. For a pipeline, you care more about throughput. For like the JavaScript one, you care more about latency, and we got fantastic latencies, sub 100 millisecond latencies for the use cases where you care about latencies. But like I mentioned, we have different products that solve different use cases. And for the ETL pipeline, you'd care more about throughput, not so much about latency, most likely. And for that, we've got a different solution, the pipeline solution, that gives you very high throughput. So you should be able to pick and choose the solution you need for your use case that should give you acceptable performance guarantees.
Excellent. I think that about covers the questions that we had for today. So thank you, Manish and Daniel, for the presentation. I thought it was very clear and concise. So thank you. Let's get to the last slide and we can wrap things up. All right. So for those who have learned a little bit about Skyflow and have seen some value, we'd love for you guys to take a look and get started with your own demo or trial.